Hello, everyone. Dr. Sveta, welcome back. Thank you so much for joining us again. And today we are continuing our conversation about Parkinson disease and brain health. And last time we talked about glutathione, one of the brain's important natural defenses against oxidative stress. And research suggested that glutathione levels in the brain can decrease early in Parkinson's disease. And that's important. When our natural antioxidant defenses are reduced, brain cells can become more vulnerable to oxidative stress. We also talked about protandim NRF2 last time, that it activates NRF2 pathways. They help cells produce their own antioxidants, including glutathione. So today, I want to take one step further. Dr. Sveta, tell us, why is oxidative stress so damaging to our brain cells?
Well, guys, good evening, good morning, good afternoon, wherever you are. And as you see, I have an amazing third party with my cat presence. So that's just the validation. So thanks for this question. And again, guys, I want to emphasize that I'm not a neurologist. What I like to do is I like to dig into the reason, into the bottom line, whether it's a Parkinson disease, whether it's Hashimoto thyroiditis, whether it's a ulcerative colitis, whether it's a heart disease. I like to dig into the bottom line. We know the drugs, we know the medicine, but the process, because everything what I just said, it's a chronic disease. It's basically a chronic inflammation. Parkinson disease is a neurodegenerative chronicity. So the idea is, when did it start and what precipitated it? And how, in my case, because everything to me applies into the cellular health or the cellular dishealth or disease, what happened? So when I think oxidative stress, absolutely. So you start digging into what caused that disruption in the cells, what kind, for example, and I started digging into Parkinson's disease. And apparently, yes, we're not going to talk about genetic component, because geneticism or geneticism in Parkinson's disease, it's a very minor component of the disease. It's there. What are the main issues? The environmental issues, aging issues, and then genetic issues, and then compilation of everything of the above. So when we start talking about aging, when we start talking about environment, and when you start digging into the etiology or the pathogenesis, how did it happen? Yes, environmental causes come on what? Metals, heavy metals, herbicides, pesticides, BCPs, and that obviously did not happen like yesterday and today someone developed Parkinson's disease. So what happened? And then when we're dealing with this chronic exposure, because we are dealing with this multi-yearly chronic exposure to this thing, what happens? It creates what is called cellular garbage or cellular toxicity. What is cellular garbage or cellular toxicity? It's an oxidative stress. It's free radical barrage. So that, Maria, probably the answer to your story, why oxidative stress is a cellular culprit in so many chronicities, because the cell, again, as one of the compartments of aging, the cell is not able, getting older, is not able to combat that free radical barrage. And then us being exposed to these environmental toxins or environmental hazards with a cellular inability to fight with this, it creates that oxidative stress, and that is going to lead to some sort of a chronicity. And what happens with Parkinson's disease, what is Parkinson's disease? Parkinson's disease is malfunction of a part in the brain that is called substantia nigra. Substantia nigra is basically translated black substance, because that black substance that produces dopamine, and that dopamine allows us to move. That's why when there is that Parkinson or Parkinsonian symptoms or Parkinsonism with this stuff, you start seeing people that are rigid. They cannot able to start movement, or they're jerky, or they're jittery and they're shaky, because there is no that fluidity from dopamine, because there is no dopamine. And that oxidative stress is detrimental to very, very vulnerable, what is called dopaminergic neurons, or cells that make dopamine. Well, the interesting thing now, I'm going to tie it up with mitochondria and obviously glutathione. Because if there is that oxidative stress and inability of cells to clean it, what is one of the main culprits, amongst others, is NRF2 cellular production or activation of NRF2. Why? Because it is not able to activate the genes that make glutathione. But then what happens with that oxidative stress and dopaminergic neurons? Well, why mitochondria is so important here? Because those neurons are actually one of the highest in the number and concentration of mitochondria in the whole body. Up to 5 million mitochondria in one dopaminergic neuron. That's the importance of that cell. That just tells you how much energy this cell requires in order to produce that dopamine. And that's why we start connecting the dots. Environmental hazards into oxidative stress, into NRF2 dysfunction. From NRF2 dysfunction, we get into mitochondrial dysfunction. From mitochondrial dysfunction, it literally leads to neuronal or cellular dysfunction and inability to make that neurotransmitter. Here comes the disease. And that is why we keep knocking on the doors. People, this is not about supplements. This is not about the sale of the supplements or something. No, this is something about the logic and the common sense of how to actually upregulate the cells. And that's why I honestly, I don't care how people upregulate their NRF2 or boost their mitochondria. I don't care, it's their gig. I know that both NRF2 protandum and NRF1 protandum are both proven to work. NRF2 protandum via the scientific research, via the publications, less on NRF1 protandum, more on NRF1 protandum through the stories, through the personal connection, through the testimonials. That's why. And that's why we're so adamantly trying to educate people. This is not about selling. This is about educating. This is about helping. This is about people to start making aware what's happening in my life. I mean, mine, everybody else's.
And I guess that will be our next topic for our conversation about mitochondria and the REF1.
And a rough one. And then not only we need to talk sort of, I can introduce you to why mitochondria actually is the essence of the cell, it's the brain of the cell. Mitochondria is a conductor of the cell, not just giving the energy, actually conducting the cellular function. But then we need to get into this, the inside the mitochondria and go through some stages how actually it functions. Why everybody talks about NAD or NAD? Why? Why is it so important? Because it's like one of the sparking plugs that initiates multitude of steps, which is finally leading to giving the cell literally the power, the energy that solar panels.
Excellent. Thank you, Dr. Sveta. For those who are joining us first time, Dr. Sveta is a senior breast cancer pathologist in one of the largest hospitals in Canada, physician certified in anti-aging regenerative medicine. Dr. Sveta,
And
thank
not a
you.
and not a neurologist. No.
Not a neurologist, a
No,
full
I did. I
pediatric
study
surgeon who is not a
cells.
neurologist. Yes. Dr. Sveta, thank you for your time. We'll continue next week. Have a great
Thank,
evening.
thank you very much. I cannot wait to continue with the series because I think, guys, it's absolutely awesome. Again, to love, to life, to kindness. Go outside, breathe the fresh air, and smile. Thank you, guys.
Thank you, Dr. Sveta.